Okay, so this is 10.2, number 31. I don't know why someone was having a hard time with this one. You must just be making an error. Remember, you guys, with these ones, a lot of times, if you're getting it wrong, you need to retry it again and again and be extra careful because a lot of times you just made one simple subtraction error. So just keep that in mind. Okay, so if we look at this one, we're going to eliminate a variable like, I don't know, x. So I'm going to take the top equation. I'm going to write the second equation, so x plus 2y minus 3z equals negative 3. I'm going to take the top equation and I'm going to times that by negative 1. I'm going to eliminate x. So if I do that, I'm going to get negative x and then minus y plus z equals 0. So when we add straight down, we would get y minus 2z equals negative 3. Then take another two equations and choose to eliminate that same variable. So I'm going to go ahead and choose the top equation, x plus y plus, I'm going to take the bottom equation. I'm sorry, we're eliminating x. We want to eliminate the same variable. I'm going to make a little note. We eliminated x. We're eliminating x. So we'll take the bottom equation, 2x plus 3y minus 4z equals negative 3. And we'll times the top equation by, instead, we want the x's to cancel out, so negative 2. So that's negative 2x minus 2y. Sorry, let me readjust here. Minus 2y, and then I get, oopsies, plus 2z's equals 0. Add straight down. X's cancel out. We would get y minus 2z equals negative 3. Then you start that process over. Now choose to eliminate or use substitution for this point. I'm going to take this and times it by negative 1 and eliminate y. So then I have negative y plus 2z equals 3. So then add straight down. We get 0 plus 0 equals 0. Does 0 equal 0? Yes. So then the answer is we have all real numbers. Now with this, we do have to write it that special way. So we have to choose a variable to remain the variable. Remember, our answers are written as x, comma, y, comma, z. We're going to choose a variable to remain the variable, and then we're going to rewrite these in terms of that variable. So because we can't just write all real numbers. Yeah, z might be all real numbers, but if that's the case, then it falls in certain places of intersection for x and y. So I usually look back at one of these equations. We have y minus 2z equals negative 3. If there's a variable I can easily solve for, I'm just going to go ahead and solve for that. So I'm going to, you know what though, the back of the book a lot of times I've noticed leaves z as z, but there are multiple correct answers. That's what's hard. So you can rewrite this 3 different ways. I easily can see that I can solve for y really easily by adding 2z. So y equals 2z minus 3. So I like to say I'm going to leave y as y. So then I have now blank, comma, y, comma, z. Well, what's z equal to? Oops, we'd have to get z alone. Oh, let's leave z as z. Let's leave z as z because look, this is what I meant to say. Sorry guys, I really am just as rusty as you guys as when I take off a break. So because we have the equation written as y equals an equation of z, we're going to want to leave z as z. Because see, now we can rewrite y in terms of z. So instead of y is equal to 2z minus 3, we're going to write 2z minus 3 there, since that's what y is equal to. See, y equals 2z minus 3. So now you have to rewrite x in terms of z. So I go back to one of the equations. I'll just take that top equation. X plus y minus z equals 0. Now you're trying to get x equals alone because then you can replace x with what x equals. So let's go like this, add these over. So we would have x equals, if I add z, I'll have a z and subtract y minus y. But remember, you have to choose only to have z in your equation. One of these can be the only variable in your equation. So we know that y is 2z minus 3. Let's insert that in. X is z minus parentheses 2z minus 3. So x in terms of z is negative z minus 2z. So that is z minus 2z plus 3 because I would distribute my negative. So then that would be z plus 3. So z plus 3. Now from there, a lot of times the back of the book, instead of having z, they'll just like put a random variable now like t. So they'll say, okay, but it doesn't matter, guys. A variable's a variable. So from here, your equation would look like this probably in the back of the book. T plus 3, 2t minus 3, and t. And it doesn't matter, like I said, which variable you use. So that's actually the most pretty answer. If you just stick with z, most of the time that's the time the back of the book writes it. So most of the time that's the nicest way. We could have chose to leave y as y, but then we would have had to have z in terms of y and x in terms of y, which would have also been correct, and so on and so forth. So I would just always stick with, let's leave z as z, and then get y equals in terms of z, get x equal in terms of z, and then there's your all real numbers statement. And then they switch out the variable with t, but it doesn't matter. Like, I would accept this answer right here instead of having variable t. It doesn't really matter.